Welcome to another video from ExplainingComputers.com. This time we're going to take a look at this, the Lichee Pi 3A. This is a new RISC-V development board with an octa-core K1 system on a chip. So let's go and take a closer look. Right, here we have our Lichee Pi 3A and specifically one with 8 GB of RAM. This I purchased from AliExpress where they cost $99 or for me £77.99. However, there's also a 16 GB version for $159 or £125.19. And as usual in my RISC-V videos, I want to stress that this is a RISC-V development board for those wishing to develop for or experiment with RISC-V. So let's open it up. Should be very simple, I think. Slide off the outer like that and oh, big pop to open it up. And a bag on top which contains, looks like that's a cooler and a USB lead, I think. Let's get them out. Yes, most definitely a USB lead, and most definitely also a cooler and a thermal pad. And then down here we've got the SBC itself. Let's get this out. Not quite sure how. This is well fastened in. There we are. Look, here's our new single board computer. Always exciting to have a new single board computer. And as you can see, it's a modular design. We have a SOM, a system on a module on top. This is known as the LM3A, the Lichee Module 3A, and this is plugged into a carrier board. And just before we go through the specs, I think it's worth comparing this with two other RISC-V single board computers, which are the Lichee Pi 4A and the Banana Pi BPI F3. And if we put the new Lichee Pi 3A down between the two, we can see it's very similar to the previous Lichee Pi 4A. And indeed you can purchase an LM3A module and use it on the previous Lichee Pi 4A carrier board. However, there is a big difference because if we turn them over, we find on the Lichee Pi 3A carrier board, on the bottom we've got two M.2 slots we didn't have on the previous Lichee Pi 4A. And I've also included here the Banana Pi BPI F3, and if you're wondering why, it's because the previous Lichee Pi 4A used a quad-core TH1520 system on a chip. However, the new Lichee Pi 3A uses an octa-core SpaceMit K1 system on a chip, which is the same chip found on the Banana Pi BPI F3. And so the new Lichee Pi 3A is a bit like a hybrid of the Lichee Pi 4A and the Banana Pi BPI F3. And in this context, it's worth noting that the C910 RISC-V CPU cores used in the TH1520 have been found to have a major security vulnerability called Ghostwrite. And so this may explain the release of a new Lichee Pi with a different chip. Now, as this RISC-V board is modular, let's start by removing its SOM, which has got a SODIMM form factor. We can just unclip it like this and that. And if we now take the SOM out and put it down over here, there we go. Let's have it the right way up. Although in fact, this is the wrong way up to look at its system on a chip, which is our K1 in the middle there. Let's use the magic of filmmaking to correct that. And then note that the K1 has 8 64-bit RISC-V x60 cores clocked at up to 1.6 GHz. These are coupled with an IMG BXE232 GPU clocked at 819 MHz, which supports OpenCL 3.0, OpenGL ES 3.2 and Vulkan 1.3. However, it's interesting to note that this GPU is less powerful than the IMG BXM464 used on the Lichee Pi 4A, not least as that GPU offers 4K output, whereas here the maximum is 1080p at 60 frames a second. This said, this is all I ever use, so for me personally, it's not a downgrade. Oh, and finally, the K1 offers 2 TOPS of neural compute power, which again is less than the 4 TOPS available on the Lichee Pi 4A. Also on our LM3A module, we have our RAM, here 8 GB low power DDR4, as well as 32 GB of eMMC flash storage. And we will take a look underneath. There's nothing really exciting to see underneath, but we should be comprehensive in these reviews, although I think now we will take this SOM and fit it back in the carrier board. And the carrier board, of course, provides all the connectivity, and specifically on the front edge we find 2 gigabit Ethernet ports, 4 Type A USB 3 ports, and a barrel jack that can power the board with a 12 volt 2 amp input. Spinning 90, the only things to arouse our interest are 4 buttons labelled wake, power, presumably shut down and record, although other than that there's nothing else on this side, so we'll rotate 90 again to once again raise the excitement level, as here we find a full-size HDMI connector offering 1080p at 60 frames a second, together with a 3.5mm audio jack, 20 pins of GPIO, a wireless antenna connector, and a reset button. And then right on the end we also have a USB-C connector that offers USB 2.0 OTG for programming the eMMC, and which can also be used to power the board via a 5 volt 2 amp input. Behind these connectors we also find a boot button, a wireless module that offers Wi-Fi 6 and Bluetooth 5.0, a speaker connector, and what appears to be a header for an additional USB 2 port, although SiPi don't list this in their specification. Lastly, turning to the fourth edge, we discover a 2-pin CPU fan header, as well as header pads that can allow a power over Ethernet module and another power header to be added to the board. As we saw earlier, underneath there are 2 M.2 slots. Here they are again, very exciting. These are both M-keyed, they are both 2280 slots, and each of them is PCIe 2.0 2-lane, and each of them can take an NVMe SSD. Alternatively, these slots can also take a PCIe to multiple SATA adapter, and in theory an external GPU. Also underneath we find a microSD card slot, a MIPI DSI connector with an accompanying touch panel connector for adding an LCD panel, and 2 MIPI CSI connectors, one 4-lane and one 2-lane as we can see, which can be used for hooking up cameras. And so there we are, SiPeed's Lichee Pi 3A, a new RISC-V development system with an impressive and very flexible specification. Right, I've now fitted the cooler, as you can see, which just sticks in place on its thermal pad, which is somewhat novel, and I've also plugged in a Raspberry Pi 4 USB-C power adapter, as well as HDMI, keyboard and mouse, and Ethernet. And in theory, this is all we need to do to start desktop RISC-V computing, as the Lichee Pi 3A comes with Bianbu OS pre-installed on its eMMC. And this is a version of Ubuntu customized for RISC-V, so in theory it's just going to work. So let's turn on the power. There we are, I've turned on the power. Hopefully something is happening. Yes, we have something on the screen straight away. We'll do this in real time. This is fairly obviously my first time doing it because this is the first boot. It seems to be going rather well. It's always reassuring to see text on the screen, isn't it? Don't know how long the first boot's going to take, but we'll stay with it. It's exciting. I like booting up new boards, particularly RISC-V boards, because it just feels like you're on the edge of a frontier. You're a pioneer with something. We're a pioneer with blackness at the moment, but hopefully we'll be a pioneer with something. Yes! Look at that. We have to have faith, don't we? Here we are arriving in Bianbu OS. And I think at this stage we will use the magic of filmmaking to speed on through until it's sorted itself out. And here we are with the standard first run setup for an operating system, so I'll just speed through this as well. And there we are, all done. We can start using Bianbu, which all seems to be going very well indeed. That was a very straightforward first boot on a RISC-V system. And so what I think I will now do is to have a look around, maybe make a few scaling changes, and I'll come back to you after that. Right, here I am back again in Bianbu OS, although not in the same version we were just running. And this is because a few minutes after I finished recording the last section of the video, a message came up to upgrade from Bianbu OS version 0.6 to version 1.0. And so I clicked on upgrade and the process ran through initially okay, everything seemed to be fine, but then I got some errors, the final one of which said the system may be left in a non-working state. And indeed, once the process finished and I rebooted, the system was not in a working state. And some web searching revealed that this had happened to other users trying to upgrade from Bianbu 0.6. So I went to the Lichee Pi 3a wiki, as we can see here, and where lots of different operating system images are available. We've got 5 different choices of operating system, and I downloaded Bianbu 1.0.15, which is what, if we look down here, we can see we are running here. Here we are, we've got our 8 SpaceMit x60 cores running Bianbu 1.0.15. And so what I then had to do is go back to the wiki, which explains what to do with your images. You need a burning tool. The particular tool I use is one called Titan Flasher, which I installed on a Windows PC, to which I connected my Lichee Pi 3a using a USB lead, and used Titan Flasher to image Bianbu to its eMMC, and this all worked just fine. And so I guess this does prove that this board has got decent support. There's certainly lots of very good support here in the wiki for the Lichee Pi 3a, just as there was for Lichee Pi 4a before it. And as we're now in the Chromium browser, we should probably continue our investigations here, so we'll close that down, and we can now see the GPU internals in Chromium, where we've got quite a bit of hardware acceleration, and that leads us logically to have a look at YouTube. So let's just find a way of doing that. Let's go down there and go to YouTube, and we'll just speed on through as the system takes a little bit of time. Here we go, and we'll full screen the Explaining Computers channel trailer. And here we are playing 1080p video on our RISC-V SBC. So I'm just having a thought there, miles away. Anyway, we've got good playback here. This is pretty good, and in fact, it's what I would have expected. A few drop frames at the start, but once it's settled, playback is fine. And the reason I would have expected this is that we're running Bianbu OS on a K1 system on a chip, which is exactly what we did when we tested out the Banana Pi BPI F3. So it's no surprise we get a very similar performance. And in fact, if we just come out of this and talk about this system more generally, it's also very similar to what we found on the Banana Pi BPI F3. Same operating system, virtually the same version of it, same system on a chip. It's a good experience. It's a bit laggy. Things sometimes take a while just to happen, as you can see, but they're very stable. And we can do our normal hello test in a word processor, which is of course a critical thing to do in one of my videos. Must do that. That's fine. We could word process on this system. Do we want to save this? I don't think we will. And as we're basically here repeating what I did in the Banana Pi BPI F3 video, I'm not going to do all of my normal tests, so we'll just take a little look in the menu, where you can see we have the same sort of things installed as we had on that board, basic internet stuff, all the stuff we need, LibreOffice, a couple of test programs for testing out the MPU, various sound and vision utilities, system tools, utilities, etc. And critically, we have in games, Solitaire is pre-installed. So of course, I've got to test this out because it's the law. And so I'll get on with appropriately testing out this game, and I'll come back to you after that. Well, that certainly proved that Solitaire works, and for my next trick, we're going to move on to testing out storage. And for this, as you can see, I've fitted not just a microSD card, but also an NVMe SSD and an M.2 PCIe to SATA adapter board, to which I've got connected a 2.5-inch SATA SSD, which is currently externally powered. So if we get the board back running the right way up, we can go across to the desktop, hello, and bring up a terminal. There we are. And I think we'll start with an LS-PCI just to see the PCI devices connected to the system, which looks good, doesn't it? There is our SATA controller board on Micron there, and here is our NVMe SSD. That's rather good. So let's just clear the screen and do an LS-BLK, list block devices. And there's now a lot, isn't there? Let's see what we've got. We've got the internal eMMC flash storage, that is there, MMC BLK2. We've got above that our 2.5-inch SATA SSD connected to the PCIe to SATA adapter board. We have got down here our microSD card, and we've got at the bottom our NVMe SSD. So let's run some storage speed tests, and I think we'll start with the internal eMMC flash storage, like that. See what we get. How good is the eMMC on this system? We will soon find out. 221 megabytes a second, nearly 222. That's not bad, is it? So let's move on to the microSD card, which is a BLK0 like that. This will of course be slower, but we can run operating systems here from the microSD card, so that's not a bad speed, 83 just over megabytes a second. But of course you want to know the speed of the NVMe drive, so let's do that as well. Here we go. And remember, we've got a PCIe 2.0 interface 2 lane here, so it won't be a massive speed. 608 megabytes a second though, nowhere near the speed of the drive, but a perfectly respectable speed. And then finally, let's not forget our 2.5-inch SSD connected to the PCIe to SATA adapter. So let's do that. Here we go. And what's this going to give us? Who knows? There we are, 316 megabytes a second, so beating the speed of SATA 2, but nowhere near the speed of a SATA 3 drive, which could be up to about, 540, 550 megabytes a second. But even so, these are all in their own way respectable results, and it's impressive to have so much storage connected to an SBC, and in particular to a RISC-V board. The Lichee Pi 3A is a solid RISC-V single board computer with a range of operating systems available. In this video we've been running Bianbu OS, but I've also briefly tried out Fedora, which seems to work pretty well, and in the near future I'm going to make a video covering all of the Linux distros now available for RISC-V hardware. Talking about the future, Cyped already have a picture of the SOM for Lichee Pi 5A on their website, and so I look forward to the further development of their range of RISC-V SBCs. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.